Okay, it's live now.
So we can just go through what we've been doing, Brianna, kind of, is we just take turns reading the questions, and then we kind of, if you read the question, if you know how to do it, you kind of explain it, and if you don't, then you say, I don't know, and then usually Carolyn and Patty are super smart, so they usually help me figure it out.
Yeah, I don't know about me being super smart.
Sounds good.
They're awesome, so.
Okay, thank you.
We'll figure it out.
All right. Okay. So.
Okay, you want me to start?
Sure.
Okay,
Sure.
What is the name of the important statistical result that guarantees that the sampling distribution of the sample mean X bar will be normal if the sample size is large? So, the central limit theorem?
Whoa.
Yes.
Hold on a second. That's what I have for this. Oh, they're all in a different order. Okay, never mind. Yes, I had the law of large numbers for that. Because the central limit theorem is about how with a large sample size it gets close to the population mean.
The sampling distribution of the sample mean will be normal.
Okay, so the central limit theorem states that if the sample size is large, the sample mean will be approximately normally distributed. That's it. The law of large numbers states that as the sample size increases, the standard deviation of the sample mean will get smaller. Standard deviation. So basically,
Backwards then.
the central limit theorem means all possible sample means becomes approximately normal. Law of large numbers is more accurate. That's my little notes I took anyways.
Yes. I, for some reason, got those backwards in my head.
Okay.
The central limit theorem is about the distribution being normal, and the law of large number is closer to the mean. I just got them reversed in my head.
Okay. All right.
Are we supposed to be doing the quiz while we do this? Because the quiz is in a different order.
Yeah, that's crazy.
I was like, wait, that's not number 3.
Oh, are you guys logged into the quiz already?
Yeah.
Oh, okay. I gotta go in the quiz then. I'm not in the quiz either.
They're the same questions that we were supposed to. That's in the questions from the review, but they're just in a different order.
Oh, okay. Hold on.
So this is lesson 8 group meeting, right?
Lesson 8 group meeting. Yes. So if we do it that way, we don't have to do them twice.
Look at Patty. I love it. Good job.
Well, I'm just thinking, that would be no fun.
Yeah, to go back to where was that again? So what number was this one?
Did you find it?
This one?
I haven't yet. I'm looking.
I
Maybe
I don't see it.
Yeah, maybe we'll find it as we go through. Maybe we won't.
I was looking to see if there's a true false for it, but I don't see a true false.
Yeah.
Because I didn't see any other option for it. Come on, stop freezing up on me.
Well, they didn't say they're all the same, so maybe this is just one that's not on there.
Yeah, freebie.
Must be, because yeah, it's not in here. But we know that I confused myself. You guys are right and I was wrong. The end.
Okay.
All right. So, you
So
guys
the
ready?
real number 3.
Number 3. The following variables is or are categorical. Number of animals in the local zoo, the randomly selected brand of toothpaste at a convenience store, age and years randomly selected, blah, 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 blah. I'm going to say it's B.
The toothpaste, yep.
The toothpaste one, because that's the only one that's categorical. The rest of them actually are numbers that... Wait a second. No, because the age and years... No, but the animals, those are not categorical. Okay.
Yeah.
Because the age and years could be...
But if you did something to those numbers, if you added 6 to all of those numbers, it would mean something. So that is a new, quantitative, the age and years.
Yeah. But you can't manipulate that age. But that can change. But the age and years of the vehicles can change. So, yes, it's just the B. It's just the toothpaste one.
Okay.
Which one?
The toothpaste one. B.
I'm always worried that mine are going to be in a different order than your guys's, or different, you know.
There are a few questions that are like that, but the rest of them I think are okay.
Yeah.
All right. The mean IQ test scores in the U.S. is 120 randomly selected statistics students took an IQ test, and the mean of their scores was 112. Which of the following statements is or are true? Okay, which ones are parameters and which ones are statistics? I think the 112 is a statistic.
That's what I would say.
And the 100 is a parameter.
Yes.
Mhm.
Everybody agree on that? Those answers?
Yes.
Yeah.
Stephanie?
I'm re-looking at it.
Well, I wasn't sure if you were frozen because you hadn't moved.
Sorry. I was like, so 100 is a statistic, 112 is a parameter.
No, 100 is a
That's
parameter.
what I think, yes. That's what you guys said, right? The middle two?
No, 100 is a parameter and 112 is a statistic.
Oh, okay. Yeah, but
Well,
would it 100 be a statistic because they said the score is 100, and then the parameter, I don't know.
a parameter is like your basis that you're basing your information on, kind of, you're comparing it to. Your statistic is what you're going to find with your random sample, or with your sample.
Oh, I think of it the opposite. So then you're right, if that's right. Okay.
Chime in, guys. Which one is it? If you could solve it.
I agreed with that 100 is a parameter and 112 is the statistics.
Me too.
All right.
Okay.
All right. Who has number 5?
Rotham City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values and another has extremely high property values. Property taxes are usually roughly proportional to the property values. What type of sample should we collect to gauge the residents' response to proposed increase in property taxes? And this one I said, I think it's the stratified sample, where you group them into groups and then take some out of each group.
I agree.
Me too.
That's
Wait, what did you call it though? Stratified?
modified sample.
Stratified sample. So you put the poor,
It's
the
separate.
low property values in a group and the high properties, and then you take, say, 25 out of each group.
Yeah.
And
Okay.
Okay.
Yep. Okay, stratified, yep.
So,
Okay, Go ahead, Brianna, you want to do number 6?
sure.
Okay.
When designed experiments are conducted in public school systems, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all the students in the selected classes. Which type of sampling scheme is implemented? And I said a cluster sample because
I agree with that.
okay.
Stephanie, you agree?
I'm reading it. I'm cluster. Yeah. Yeah.
Okay.
I'll do number 7. At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented? Would that just be a simple random sample?
That's what I choose, because everybody was put in, right? And they just pulled people out at random.
Random, yeah. What do you think, guys?
That's what I had.
That's what I have.
Okay.
Number 8. A special interest group is conducting a survey regarding wolves in Yellowstone National Park. To adequately gauge opinions on both sides of the political spectrum, the researchers took the list of registered Democrats and a selected simple random sample of 100 people. Then they took a list of registered Republicans and selected a simple random sample of 100 people. Which type of sampling scheme was implemented? That one was, I know this, hold on. Stratified. Couldn't remember the word. I'm like, I had to find it.
That's what I said.
Me too.
So we already had a stratified before. Isn't that weird that they would have two of them?
They like
it's a stratified random sample instead of stratified sample.
Huh?
But it's not a systemic, because a systemic is you choose, say, the third person, and then you take every...
Sixth person after that or something.
Yeah, and you choose to start, you're going to start on number 5. So you're going to take 5, 8, 11. So it's not that one.
Yeah, it's stratified.
Yeah.
All right, who's turning in for number 9? Want me to do it?
Oh, okay.
I don't care. Somebody.
Go ahead, Stephanie.
Okay, a survey was taken of purchases at the Crossroads. Open the data file Crossroads Purchases and use this data to answer questions 9 through 11.
Okay, so we already did that one. So, because you have to use the SPSS software, which takes forever to get logged into. So we'll just tell you, I got, for the mean, I got 4.77.
That's what I got. And the best way, right, to get that is using the histogram. That's what I did.
Yeah. Yeah.
Okay.
Wait, when did you guys do it? Before I logged on earlier or something?
No, we were supposed to work the problems in the review on our own before we got together.
Oh, okay.
But
So, and I did some of them while I was waiting. So I only got to number 10 and then...
no worries.
Okay.
But it says round to 3 decimals, but you said 4.77?
Yeah, so if you have the SPSS,
I still have
SPSS pulled up,
Uh-huh.
and then do you have the one for the Crossroad purchases? Can you open that one?
Hold on, I still have it pulled up. Let me grab it.
And just share your screen.
I think it was 4.771. So
Yeah, I'm trying to remember. I'm like, did it actually have more than that? I can't remember.
that's what I had written down.
4.771?
Yeah, it's 4.771.
Oh, mine only says 4.77.
That's if you do the histogram. If you do the descriptives,
Oh, it's 4.771. Okay.
It's still authenticating, still logging in.
yeah. Here, I'm trying to pull all of it up, but it's taking its time getting it up.
Did we just lose? Oh, wow.
Did you lose me?
No, I thought we lost Patty.
Oh, that's not the screen. No, it just, I was trying to click my screen share, but for some reason, because it's in 2 different windows, I'm not sure if I can get it to share.
Yeah, that's cool.
Well, we can see your... Oh, you're talking about if you can share your SPSS.
Yeah, that's what I was trying to do, but because they're in 2 different things, I'm not sure how to do that.
Yeah, that's really hard.
It's a pain. I have to log in through it. And so we won't screen share. Stop screen sharing. Because it won't matter. You guys have the same screen to look at your questions. I'm helping. So, okay, so the next question.
Oh, I think it's my turn.
Yeah, it's 4.771.
Okay, if I log into SPSS here, then I can't click to my other computer stuff. So I'm just going to have to trust you guys. So 4.771?
Yes.
Yeah.
Okay.
And then number 10, using software, calculate the standard deviation of these data. So I got 1.912.
Yep. That's what I got. Holy cow, it's freezing in my house. Hold on a second, I have to go close the door.
She lives in Arizona. So I'll have to ask her how cold it is there.
Yeah.
Audience is used to warm weather, so like 60 is really cold in Arizona. You know?
Yeah.
Now, what's it there in Idaho?
Today it was 34. taking the kids to school, and it snowed yesterday.
Oh goodness.
What about you, Brianna? Is it pretty cold over there right now?
Yeah.
We're teasing you about Arizona and cold.
Oh, I can hear you. I know it's hot here, but my husband wanted to air out the house a little bit, so he left all the doors open, and I'm like, I'm sitting here, you know, I'm barefoot and running around, and like I can just feel the breeze coming through.
And this sleeve shirt.
I know it's not cold compared to where you are, but
you get used to it.
well.
Yeah, you get used to it. You're acclimated. There you go.
I don't do cold well.
You need to come to Idaho and visit us, and then we'll get you used to it.
It's 50 outside right now, so it's not like it's, you know, toasty, but it's warm compared to where you are.
How cold is it, or what temperature?
52.
Oh, that is cold for Arizona. That would be really cold.
Like
And
I said, I'm cold.
It was like 45, 50 here, and it would be cold if I left my doors open. Okay, I'm not going to tease you anymore. I'll stop.
Okay, it is warmer here than usual. Yesterday, I was running around in capris, flip-flops, and a t-shirt. So,
Oh goodness.
yeah, we're getting our little cold front again. It's starting to chill up again. Chill up. We're starting to get cold again. Anyway.
Yeah.
Yes, sorry. Okay. It's okay. I can take the ribbing because I know I'm a wuss. I'm a sissy when it comes to the cold.
That's okay. I think we're just mostly jealous, so, you know, teasing usually comes from jealousy. So. Although, Carolyn, you're in California. It's got to be, are you southern or northern?
I'm Southern California, so
Warm weather, too. So
yeah. Yesterday it was 75.
Oh wow.
nice, yeah.
We had a hard time because we aren't always at this time of year.
Yeah.
The kids were freezing when they walked out the door this morning. It was in the 40s. They're like, it's cold. I'm like, yes, the jacket.
That's how I am. It's 45 this morning, and so I'm like, this is too cold.
Where's the sweater?
All right, let's
Okay.
keep on keeping on. A whole bunch of blah blah blah, and they're telling us all the different temperatures, all the different locations that they.
So,
Well,
but make sure you do number 11.
Yes. Oh, number 11. Did you guys create a histogram? I created a histogram.
Yes.
I
did.
put it through because that's what Carolyn was talking about.
Okay.
Yep.
I'm
So
gonna have
just
to go back and do those so I can understand how to do it.
create a histogram. It's easy. You click a couple of buttons and
Does it for
it does it.
you? Okay, good.
So
I
now,
wanted to log on, but it wouldn't let me.
so number 12. What's the value? I don't know whose turn it is. I just jumped in. Sorry.
Go ahead.
What's the value of the number that goes in the position marked A in the above table? So we just figure that out, and I got. Where's that paper? I got negative 0.165.
Me too.
Okay.
Wait a minute. Okay.
Can you guys tell me how you did that?
Yeah, was our or do we have to go in and get our mean out of the?
You'll have to add those four numbers together and then divide them by 4 to get your mean. And you
Oh.
subtract. You'll take 37.91 and subtract that mean that you got.
Oh, from Bodil, whatever.
From this, yeah. So we're going to be just put Bodil or whatever, however you say his name. You're going to take his x and subtract the mean, which after adding those 4 and dividing them, you get 38.075. So you subtract 38.075 from the 37.91, and it gives you A.
Oh, okay. So that's why it's negative 1.65. Got it.
And then number 13 is B. So you do the same thing for the deviation from the mean, and then you square it.
For that one, I got 0.68.
You get 0.68.
Yeah.
Let me redo it because I may have done it wrong then, because that's not what I've got. I got point. I got where? I got. Oh, I did. 0.68. I just wrote down the wrong one. In my chart, that's what I have, but under the answer, that's not what I wrote.
So.
Yeah, 0.68. That's what I've got too.
Okay, hold on. I'm doing my math here.
Apparently, I'm dyslexic too, because I punched in my numbers backwards.
So you got 0.681.
I didn't get 0.681. I got 0.68. Let me see if I dropped to something.
Wait, I got what? Okay, I did it wrong. Wait, what'd you guys get? What point one? What'd you guys? Wait, I got 0.106, but I think I got my numbers backwards.
I got 0.681.
Oh, that's what I got too, actually.
Okay.
I just had to redo it.
Yeah, I think I dropped the 1. I rounded off too short.
So you do 37.25 minus 37.575, because 37.575 is the mean, right?
I just didn't round up. Yeah, that's 0.1. What? What'd you say?
I think the mean is 38.075.
No, the mean is 38.075. So the deviation from the mean, and then square it.
How did I do wrong on the mean?
The mean is just those 4 numbers added together and divided by 4.
I did that, and it equals 152.3 divided by 4 is 37.575.
I got 152.3 for the total of those, and then divided by 4 is 38.075.
Oh, I did 36.98 instead of 38.98. Okay, that would change everything, obviously.
It's all good.
Okay, so what did you guys put down for B, or do you guys want to wait for me to do all the math?
That's okay. It's 0.681.
Yeah.
Plus.
Okay. Who's
So
got
number 14.
Mm-hmm.
What quantity is equal to the sum of the numbers in the square deviations column? That would be the mean, correct?
Nope.
Oh gosh. The variance.
The variance.
Okay.
I didn't know. Yeah.
It's the variance because you get the mean by totaling up the first column and dividing by 4. You get deviation from the mean. That's the second column, but we don't do anything with that. We use that to find the square deviations. When you add up the square deviations, that gives you the variance, and then when you take the square root of that sum, that gives you the standard deviation of.
Okay.
So that's in lesson, I found it, lesson 4, 3.2.1. Where it talks about that.
Yeah, it's in lesson 4. When they were doing the probabilities. There's actually a slide that he showed all that. He showed all the columns, and he says this is the variance is the sum of all of those, and then the deviation, standard deviation, is the square root of the sum of all of those.
Okay.
Thank you.
So go back to lesson 4 if that one's a little tricky or sticky for you.
You guys put the standard deviation, is that what you said?
No, the variance for number 13 or 14.
You said, explain for just a second. You said the standard deviation is the square root of that?
Because the square root of that is the standard deviation. But we're not doing the standard deviation of it. We're doing the variance. That's the sum of those numbers is the variance. The sum of the numbers in the square deviations is the variance.
Okay.
Lesson,
yeah.
And then we had to figure out the standard deviation of those temperatures. So we
have to do all the math for all of that, and then.
So you add up all the square deviations. Hello?
Somebody in your house? I
don't know. I just heard a noise. Smalls, go get him. What kind of guard dog are you?
Tell.
He's just looking at me like, what? What's wrong?
But if your dog didn't turn and look at it or bark.
He sat up and his ears kind of perked, and then he just kind of stood there.
You want us to wait?
Well, the garage is closed. The only way they could get in is through the front door, and I locked the front door.
Maybe there's a mouse.
Yeah, maybe we have rats. I've had rats before at another place I lived, and it's not pleasant.
Rats? Not mice, rats.
We have both. We lived at my parents' house for a little while in the transition, and the apartment above the garage, because nobody lived there forever, they didn't know that they had them there, and we're in there, and it was like midnight, and I'm on the couch reading because I couldn't sleep, and I heard a noise in the kitchen. I go in there, and I found a roof rat. I'm not kidding you. Nose to tail, and I am not exaggerating. I mean,
Did you scream and wake up the entire house?
I screamed bloody murder, and my husband comes running out. What? I told him what's going on. So then we spent the next 20 minutes tracking this thing down, moving the refrigerator. I'm standing on top of the table. He chased the thing. He chased it into the bathroom, and slammed the door. And he's like, I can hear him yelling and things banging around. He grabbed the plunger. He had the thing stuck pinned to the door with the plunger, and I see the little nose coming out of the door, and I'm still screaming.
Oh, gosh.
He plunged it into shock until he could put it in a garbage bag, and then he's beating the bag against the wall. Oh, memories.
Poor rat. But if you see one, there's usually more. That's the scary part.
Yeah. We ended up with that. I couldn't sleep. He's like, okay, fine, we're good. Are we good? Can we go to bed now? And I'm like, are you kidding? I'm not sleeping.
I have so much adrenaline right now. I'm not sleeping for the rest of the night. That's funny.
For a week, man. So we went and sealed any little crack we could find anywhere.
Yeah.
Put out sticky traps everywhere. And we found over the next 2 months, we probably found, I don't know how many rats. There was like 2 more rats, I think, and the rest were mice. But there was like, we had almost 24 things that we caught in those sticky traps.
Oh, wow.
Oh, wow.
I came home and one was squeaking, and I'm like, I can't, I'm not doing this. And I went and got my dad. I'm like, Dad, will you please come get this squeaky thing out of my apartment?
I can't do it. Please don't make me do it.
Like, I am a 30-something-year-old woman, and I cannot deal with this stupid squeaky mouse in my kitchen.
We've had mice here, and I was like, I'm ready to burn this house down. I feel so invaded.
Yeah.
And we finally, I'm like, this is it. This is war. So we call the set kind of traps all over. I got 3 cats. And
I have somebody at my door. I will be right back.
okay, so the standard deviation of the temperatures. Do you take the find the mean and then minus all of them, and then do 1 minus that difference, or what? How do you do the standard deviation? Oh, that's the square root, the square.
So then you minus all of them, right? Then you have to square root them.
So wait, just a minute. So like say Bodil or whatever, right? The crap. Why did I write it down?
Okay, so what do we do? We're still figuring out number 15?
Yeah. Who is at your door?
Oh, FedEx was delivering a box from North Carolina for my husband. I have no idea what it is.
It's a surprise for you for your anniversary.
Which is probably not our anniversary. Although our anniversary of the day we met was only a week ago. I just realized that. Huh.
Aw, that's nice.
We've now known each other for 22 years.
Oh, wow.
That's nice. How long after you met him till you got married?
Just over 2 years, just shy of 3, because we met in January. He left on his mission in May. 2 years later, he got home in May. We were married in November.
Wow.
You waited for him? We dated other people a little bit.
I dated a lot. Months. The first 6 months were miserable. I did not date, and if I tried to date, I ended up going home in tears, sobbing because I just couldn't do it. It was the worst. But yes, I did date while he was gone.
Oh, and then he got back, and you're like, dude, you're the one, whether you like it or not. We're getting married.
Yeah, that's how he took a little longer to get on board.
I'll wait for you. You'll figure it out.
He went to California to visit some girl from his mission for like a week after, like about 2 weeks after he got home from his mission.
Uh-huh.
I took him to the airport and picked him up, but he didn't contact me the whole time he was there.
Oh.
I would have been hurt by that.
Trust me, that took years for him to live down.
He's like, but then I was really sure, and yeah.
He gave his mom all the contact information or all the information for me to go pick him up at the airport, and had her call me to know when to come get him. I'm like,
Oh my goodness.
Should you call me?
That's a young man for you, though. Now, of course, he would do it, but he's just young.
Brianna,
What's that?
Brianna, are you married or single or what's up?
I'm single. I'm a returned missionary, but I'm single.
Well,
Hey,
just-
where'd you go on your mission?
Boys are dumb.
Orlando, Florida.
Awesome.
Yep.
Well, boys are dumb. They do figure out their stuff, but they take a while. Sometimes it's because we tell them what's up.
I can agree with
So, in case you're wondering.
Thanks.
All right. You guys
Okay, so number 15.
This is very normal, Brianna. We kind of get off track sometimes, but just come back around. Just hang with us. We'll be back. Okay, so guys, tell me how to remind me how to do this. So the standard deviation of the temperatures. So I'm going to take the 38.075, which is the mean, and then minus it from 37.91, and do it for all the different numbers.
Well, you're going to subtract the mean from each of the numbers in the representative temperature column. So that first-
Okay, so 37.91 minus 38.075, right?
Yes, and you'll do that for each of those numbers, and you'll have a number. And that's the standard. That's the deviation from the mean. Then what you'll do is you'll take that number and you'll square it, and that'll give you the squared deviation.
Okay.
And then once you've got all four of those, I'm going fast. You following?
Yeah. Well,
I'm not back done yet. I'm just saying, do you understand the process?
yeah, but keep going. So you minus the numbers, the temperatures, then take that minus the mean, the 38.075, and then once you get all those numbers, then what do you do with them?
Then each of those numbers you individually square. So for the 37.91, the deviation is negative 0.165. You'll square that and get a 0.027. Then for Roberta, take her number, you subtract the mean from it, and you get the negative 0.825. You square that, and you get the 0.681. And then you do that for each of those. And so once you get all those four standard deviations now for all the data, you'll add all four of those together, and that gives you the sum. That sum right there gives you the variance.
So you take the sum of the standard deviations, right?
The sum of the squared deviations gives you the
Squared.
for the standard deviation, you square root the variance. Am I on track? I'm not wrong, right?
I think so. Yeah, I think you're good.
You understand it? That's how it is too. I'm like, I don't want to explain it wrong. So if I'm wrong,
No, I think you got it.
okay. So are you okay, Stephanie? Do you understand where we're at now?
Yeah, I was just gonna actually do it. So the next one would be 0.905, and then you're going to take the square root of that, right? Square it or square root?
You square it to get the square deviation. You square it.
Okay. And so for that one, for Larry, you got 0.819.
Yes.
That's my birthday, kind of.
When is your birthday?
819, August 19th.
That is the day that Adam proposed to me.
That's a good day.
And ironically enough, that's also the date of my first kiss when I was 16. I remember that.
The thing is, if you ask the guys if they remember this stuff,
they don't care. They're like, I don't know. It was like summer.
Wasn't it summer? No, I was wearing a huge coat. No. Okay, so on the last one on pair, whatever,
Yeah.
0.085, and then you square root that,
Square.
square that is what I meant, sorry.
Yeah.
And is you got 0.007?
Yeah.
Okay.
And then you could.
But do you just round it to 3 decimals every time, or do you keep the whole long number?
I was rounding to 3 decimals.
Okay.
And then what, we have to multiply that by 0.25, correct?
Why? These are just the square deviations.
Oh. I wonder what I have.
Were you thinking of like the proportion thing?
I don't know. I'm on where in the lesson when it talked about rolling the dice, and then because you have a 1/6 of a chance of.
Yeah.
That's different, huh? Okay.
You're trying to figure out.
And so did you guys get 1.239?
Mm-hmm.
Yay!
1.238. Did I round it off wrong?
Well, it's 1.2385.
I probably just didn't round it.
Okay.
So we're either all right or all wrong, except for Caroline.
Well, yeah, because I multiplied by 0.25, so.
Well, because I'm looking at what it says with the square deviations. All it says is square deviation. It's not dealing with the probability of. It doesn't say anything about the PX.
Okay.
You know what I'm saying? It didn't have us because it doesn't have. There's no probability here.
Okay.
Where's Colby when we need him?
Seriously. This is where we turn to him and say, Colby, explain it to us.
We didn't ask if Colby was married. We need to set up Brianna and Colby.
There you go.
Oh dear.
This over here. Just kidding.
It's good you're broadcasting this.
I know, right? We're recording it. Nobody watches it.
That's funny.
Colby, if you're watching this, I'm just kidding.
So
Brianna's gonna leave and she's never gonna come back. I'm sorry, Brianna.
No.
1.238.
Or
It's
1.38 or
1.5, so round it up to 9.
It is not okay because I got 1.23814. Okay.
Let me do it again. I'm going to add my numbers together again.
Okay.
Well, didn't you get as the sum of the standard deviation? Did you get 1.534, Carolyn? When you summed up all of those.
I didn't write it down, but I have 0.027, 0.680, 0.819, 0.007.
So on the second one on Roberta, I got 0.681.
Yeah, that's what I have too.
So if you that one is 37.25 minus 38.075 equals negative 0.825.
If you do a 0.0, then you end up with. If you do the 0.0 on Roberta, then you end up with the standard deviation of 1.2381.
Okay. So yeah, when I checked my math on Roberta again, I should have rounded up. Okay.
Okay.
So 1, 2.
Here's how one little thing will change the whole answer.
And then you wonder, okay, how much are they going to get off that one thing at the 1,000th place, you know?
Right.
But I'm sure that there's places that it makes a huge difference. All right, moving on, or we're going to take forever because we keep getting off track.
Okay.
Under certain conditions, the standard deviation can be negative. Never.
False.
Okay.
All right, who's up? Brianna, go.
Okay.
You don't have to read that because I think we've all read it. It's about where the different placements of the temperature of the thermostat.
Okay. So which location resulted in the most consistent temperature measurements from one seal to another?
Mm-hmm.
I said extradural.
Yep, that's what I said too. Do you guys know why?
Because of the standard deviation?
Yep.
Is
that right?
Smallest?
It's the smallest standard deviation.
Yeah.
Which means
I actually have like another group that I'm studying for like pretty soon, so I might have to go.
No problem. We'll try to bust through this as quick as we can. We'll try not to go off track anymore.
Oh,
And
no,
if you
no
have to
worries.
go, you can watch the rest of the video later.
Okay.
And go,
Okay.
dang,
All right, I can define standard deviation. Yes. Can you define the standard deviation?
yes,
Yes.
I can. Okay. The number of hours that students spent studying for an exam were recorded. The data are represented by the box plot below. Use this box plot to answer the survey. So what is the third quartile? Is it 8?
Yep.
That's what I would say. Okay.
Yep.
Okay,
Tw-
what? Oh,
go ahead.
sorry. What percentage of the data lies between 4 and 8 hours? Don't include a percent sign. So 50% of the data?
Yep.
That's what I said.
That's what I would put.
So for 21, estimate the mean of the measured nitrate concentration in Rexburg's drinking water. I got 2.055.
That's what I've got too.
And I have to do the math because I didn't do the math.
Can you guys tell me how you figured that out? Okay. Estimate the
Yes.
mean of the measured nitrate concentration. So the
So from the problem above,
Oh,
it gives the where it's between. It gives the two standard deviations. It says
1.5. Okay.
yeah. So you take those, since we don't have any other data, you just add those two together and divide them, and whatever's right in the middle is the mean.
mhm.
Okay.
And then for number 22, to estimate the standard deviation, we have this two standard deviations. What we need to know is what one standard deviation is. So we need to subtract the one standard this one of those numbers. So I just subtracted the 1.59 from the 2.055, and that gives me a number, and then divided that in half, and that told me what each of those standard deviations is, how far apart they are. It split the difference. So this one standard deviation is right in the middle of those. Does that make sense?
Okay, right.
And I got 0.233. Is that what you got, Brianna?
Yes.
0.233. Yes.
So then from there, 23. Brianna, you want to do this one?
Sure. Between the two measured nitrate concentrations do approximately 68% of the data values lie, and I said 1.822 and 2.288.
That's what I got too. You guys know how we did that?
Well, you have to find the, if you find the z-score right, then
No, you won't do z-scores on this one. With this one, what you'll do is you'll take that standard deviation that you found in 21 on the paperwork, or what we just found in number 22. You'll take that number and you'll add it and subtract it from the mean, and that'll give you the bookends.
oh, okay.
So
One standard-
2.055 plus 0.233, and then 2.055 minus 0.233.
Yeah, and that'll give
Yes.
you your standard deviation, your one standard deviation, which is what
Yeah.
the 50% is.
Okay, that makes sense.
Yep.
Okay. All right, so 24. What is the value of a mean normal mean? Okay, that was the 0, right?
I think so.
Why is it 0?
Because, well, if you're looking at the applet of a standard normal distribution, the mean is, and the standard deviations are 1.
Yeah,
Oh,
so 0. Okay.
Of a standard normal distribution. So it's 0. I see what you're saying. Okay.
Lana's the one that got this one, because I went, I don't know. She's like, well, isn't it? I'm like, that makes total sense.
I hope. I don't know.
Well, you're ahead of us, because it makes a lot, because I was looking going, we can't define that. We can't. There's no information.
One, right?
And then I realized it's not talking about this problem. It's talking about a standard normal
Yeah.
thing. Well, standard normal distribution, it's 0 in the middle, and 1 standard deviation, 2 standard deviations.
3.
So what is the value of the standard deviation of a normal distribution? That would be 2, right?
No, it would be 1.
One from
I
each.
think
Oh, 68% of the data lies within one
Mm-hmm.
standard deviation.
That would
Okay.
be standard deviation, which would just be standard deviation.
Okay.
That's how I read it. 2.
So it'd
So
be 1.
Yeah. And then 2 standard deviations from the normal distribution with 2, and then 3.
Yeah. That's when you get into 95% and the 97.9.7. All right. So here's where I didn't finish all of these ones. But
What time do you have to leave, Brianna?
Well, my meeting's not until 11:30, but I was supposed to do some work with it before, but
Oh, tell me when to go.
it's
We're gonna have to work
fine.
because we kind of have to work through these ones a little bit to finish them because I didn't finish these because I don't know why I didn't finish them, but I didn't because I think when I was going to finish them,
You're a busy mom and have a million classes. Maybe
Yeah,
that's something.
that'd be really tough.
and I have new clients today, so I have to come up with my new paperwork that I've been putting off doing because
Oh,
but
yeah,
I'm not
it's
sidetracked.
Okay.
So 542.3. So this is where we're going to be using that z-score, and it's minus u over standard deviation divided by the sample size, right? Okay. So
So we need the we're gonna need the applet. Yeah.
yes.
mhm.
Okay. Which how did you guys find the applet real fast? Is it chapter 5?
I think you can get it from the review. It has a link,
Oh, okay.
isn't it?
Um,
I've honestly pulled it up so much that all I got to do is type in
yeah, me too.
and it pops up. And actually,
Uh-huh.
in a new window, it's actually one of my options. It's one of the screens that's there. Click on.
You want the website?
It's
Yeah, 'cause I don't see it found it.
easy to use. That's pulled up.
It's byuimath.com/apps/normprob NORMPROB
Okay.
.html.
Oh, there it is. Okay. I gotta bookmark that one.
Yeah, that's what I did.
Okay. All right, so the probability that a random selected student will score above 542.3. Huh. All right, walk us through this one.
Okay.
'Cause I'm
So
zero-
on this, for this one, oh, okay. So we're on 26.
yes.
Since it was just, well, what I got was 0.5. Since it's just above like average or mean,
Yeah.
I said that like half will be above mean and half will be below.
Yeah, because that is the mean. So if that's the mean, then half is above.
Mm-hmm. Then on 27, I
wait,
just
what did you put for 26?
0.5.
50? Oh, 0.5?
Mm-hmm. Yep.
Okay.
That's the whole point of a mean is it's half is it's right in the middle, so it's got to be
Mhm.
half.
Yeah.
What that number is half. So
Okay.
now the rest.
Um,
All of a sudden I looked at one. I don't know how to do that. Well, hold on. I'm like, it is the mean. How does that change it?
So then on 27, I just subtracted 600 minus 542.3, and then I divided by 120.54, and I got
So 0.496.
478, yeah. And then I plug that into my applet.
Yeah, I got 0.479 or 4787.
Yeah, that's what I got too.
Okay. This is above. Wait, this is below, so it's gonna be left and the right.
Mm-hmm.
So I got 0.684.
Yep, that's what I got too.
Can you tell me how you did that?
Yeah.
Go ahead.
I just subtracted the 600, which is the score we wanted, from the average, which was 542.3, and then divided by the standard deviation, which was 120.54.
Oh, okay. I see what you're saying.
And then that just gives you the z-score that you type in.
Okay, I see. I'm with you now.
Okay.
Okay, sorry.
No,
So
you're good.
we're only shading left, right?
Yes.
So
Yeah.
it's 0.316?
Wait. No, it's going to be the middle and the left, isn't it? Because
Oh,
Isn't it
Yeah.
like 479? Is it not 477? 4787?
I got, well, you're doing below 600, and the z-score for 600 is 0.4787, so that's the right line.
Oh, so you did it 4 decimals.
So, well, it rounds it back down on the applet, so it's 0.479. So everything to the left of that is going to be less than 600. So,
okay. Yeah, I think you're right.
which gives you the 0.684, which if that's the number you got, you did it. You probably just forgot that that's what you did. If that's a number that you have written down, it should be 0.684.
Okay, that's what I got if I shade the center and the... That's the hard thing is I'm forgetting where to shade.
And
Yeah.
Do you shade the middle or not?
And then for everything above 600, it's just the right, or you can just do the math. But if you just click on the right one and don't click on the middle and the left, it gives you the 0.316, which is number 28.
Okay.
Okay, so we're only shading so it's 0.316. Okay.
Yeah, for 28, it's just above 600.
Okay.
So then for the
Okay,
10,
dumb question here. So 600 is obviously the right line, the 1 standard deviation off. Tell me, were you dumb? Because that's not your mean, but that's your the minimum. What do you call that line? What do you call that? What is that?
that's the z-score. It's a standard deviation.
Yeah.
Actually, no, it's not standard deviation. It's a z-score. That line is a z-score. That line is the mark that you're measuring from.
Yeah.
So, okay, so like 25, we solved for this. Found the z-score for a score of 600, and then to figure out everything that's what you'll score below 600 is everything to the left of that line. At
Yeah.
that line, that's the 600 mark.
Yeah.
So then for the next one, we want to know everybody above it. So it's just going to be the other side of that line. That line is below 600.
Okay, I understood that. I just didn't remember how we got that red line.
Oh, it's.
I mean, that's the z-score that we figured out, the 0.479.
Mm-hmm.
Okay.
Yeah.
Yeah.
Okay. Then you guys ready to go on?
Yeah.
Okay. For number 27, you'll put the 10th percentile. You'll put 0.1 in the top. Hold on here. And it's everything to the left of it, right? So it's
Yes.
We'll highlight just the left. Oops, just the left. Stop clicking things, Patty. So just the left side, put in 0.1, and you get a z-score of negative 1.282.
Negative 0.282.
Negative 1.282 for the z-score, and then you got to solve for the x. Unfortunately, I don't have my formula transmutated, and I don't want to do it right now. And I got x equals 387.77.
That's what I got too.
Are we supposed to go to 2 decimals? Oh, the nearest whole number. So it'd be 388.
Patty, tell me the formula again on 29.
29. Okay, it's gonna you're gonna solve for x, so it's gonna be x equals z times
What?
the standard deviation. It's gonna be x equals z times the standard deviation plus the mean. Am I right? The other two?
Mm-hmm.
So did you get 388?
Yeah, so the whole number, when you round it up, it's 388.
Okay.
Um, and for when we're doing above a percentile, above like for a 90%, is that the one where you do the middle and the right?
I think you just take the further right line and then
Yeah.
take everything above that.
I was just trying to remember because I don't have it.
That's what I say too.
Just
Because
above.
mean in the middle would be 50, so
Yeah.
the 90 would be the far right line.
But on the I'm sorry, I'm really sorry, guys. 29. You said you explained the formula, but what is the mean again?
That's the 542.3.
Oh, right
Just
there.
the number that they gave us.
So in that formula, you added the mean, the standard deviation, and then you multiply it times the z-score, which is 0.479 for x. But why are we doing that?
What are you doing?
I don't
Sorry.
know.
I was doing something else. I lost you.
I was trying to do 29. I don't understand how you guys did that. So the formula, and then times that times.
What you're going to do is we found the z-score for the 10%. So you click the left side of the left line.
What's the z-score for 10%?
That's what we're talking about.
Negative 1.282.
Negative 1.282. What you're going to do is you're going to click the left side of the left line, and then in the area, after you click that and everything else is empty, you enter 0.1 for the 10%. That'll give you your z-score. Then you take that z-score and you plug it into the formula, which was
So that's the, I don't know, can you see
Oh, yeah.
the formula? Can you see that? Yeah,
but Patty did does it where it's already factored, right? So it's the same thing. 1.42. Did you leave that? Sorry.
Here, it's
X equals. Do it again, Patty. You have to talk so it stays up there.
I'm writing it down for you because I didn't have it written down. So my brain just went blank for a second. I had to write it back and check it again.
Patty, show yours again because I want to write both of them down in like just.
Here's mine. Can you see it now? Is it showing?
Yeah.
Okay.
Okay.
Okay. So one.
And then here's mine.
Okay.
Well, I didn't do the numbers. This is just the formula. So the x is the variable, the z is the z-score, the theta is, or the sigma. What is this thing? This is sigma.
Standard deviation.
Standard deviation, and then the mu is the population mean.
Okay. Okay.
Okay, so that's the formula we use for that. So then for the number, so are you okay on number 29?
Well, then what did you guys get for that answer on 29?
After you do all the math, you get, you end up with a 38 or 388 after you round the nearest whole number.
388. But then your 10th percentile, so re-say that part because I was thinking about something else. So the 10th percentile and the area, you do 0.10, right?
Do 0.10. After you highlight the left side, you'll put 0.10 in the area, and that'll give your z-score.
Oh, and then you get the z-score of the point. Okay, that's what's always confused me is how, okay, so then you don't highlight the left, then you have the middle, no, not the middle.
And
So
then,
the 90th is the middle and the right.
no, for
So-
the 90th percentile, it's the middle and the left. I just went back and looked at my notes. It's the middle. It's everything below 90% is a 90%. So everything to the left of it adds up to 90%.
Oh, you're right.
Only 10% is above it. Yeah, I had to look at it again. I'm like, that doesn't make sense. So
That makes sense. Okay.
on the left, you highlight both of those, put in 0.9, and you're going to have the same z-score because you're dealing with the same percentage. But
Okay,
you're
that's
with the positive, so it's 1.282, so the number's going to change.
So on 29, you guys did negative 1.282?
Mm-hmm.
Okay. Five left.
So that ends up being I got 697.
That's what I got too.
That's what I got.
All right, cool. Everybody got that?
On that one, did you do the area of 0.25? And then find the z-score and then do the problem again?
For what are you talking about?
For 31, the first quartile?
Oh,
Oh.
Sorry, I put answer in the wrong question. I'm like, what are you on?
But is that how you would do it? Because it's the first quartile, so would you do area 0.25?
Yes, and it's everything. It's just to the left of the line.
Okay, so then you have the z-score of negative 0.674.
yep.
Yeah.
And then the standard deviation is 120.54. And then times it times, what was the mean again? I keep forgetting it. 542.3?
Yeah, add 542.3, I think.
Oh, add. Okay, thank you.
And I ended up with 461.
That's what I got.
That's what I got too.
I'm getting there. 542.3.
Close, we're getting there. Keep going.
623.
You're okay.
Well, we're trying to get done so you have time, so you don't have to leave
Yeah.
it.
You said 624, is that right? No,
Yeah.
sorry.
461.
624 is the third quartile. So instead, you must have put a positive for your 674 instead of a negative.
I did, you're right. Okay.
So you figured out number 32.
You did the next one already. Don't worry about it.
Oh, good. I'm just overachiever here. Okay, so 624 and then 376 was your 31. Tell me again.
What?
Your
31?
your third no.
First quartile was 461. The third quartile was 624.
Are you sure? That seems too high.
That's what I got. What did everybody else get?
624 for number 32.
The 31, what did you get?
461.
I got 461 and 624. But you remember that's 25th percentile and 75th percentile, so that's going to be a high score for the 75th percentile.
Yeah.
Well, and it's below our 90th percentile, so because we figured out our 90th is 697.
So
Yeah. And if you subtract like the mean, like 542.3 minus 461, you get like 81, I think. And if you add that to 542.3, then you get 623. So like.
Okay, we checked your work. Okay, that makes sense. Yeah. Okay. Okay. So 33. Consider a simple random sample of n equals 15 students taking the GMAT. What is the mean of the distribution of a sample mean score for all such samples? Bless you. Whoever sneezed.
And wouldn't the sample means be the same as the population means, right?
That's what I said.
That's what I've got too. So it'll be 542. What did I do?
542.3, is that what it is?
Yeah.
And then for the standard deviation, that's where you take the original standard deviation and divide it by the square root of the sample size.
Yes.
So it's 120.54 divided by the square root of 15, which I got 30.984.
Oh, I better do it again.
I got 31.12.
Okay, let me
That's what I got, 31.123.
I'll see if I did it wrong. Hey, I got a different number that time.
Okay.
I got 31.124.
Wait, 41?
31.
31. You said .123, the two of you, but Patty said .124.
Yeah, I got 1, 2, 3.
I looked at the 9. I missed the 2 next to the 3. I just went straight to the 9.
Oh, okay. All right.
1, 2, 3. I just skipped a number in my brain. I was trying to catch up fast. 1, 2, 3. So 31.123. All right, last one. The probability sample mean of the GMAT score for SRS and N15 students will be greater than 600. So now we've solved. Let's do the same thing. For the z-score, though, we have to use with the square rooted 15 there. So that's 31.123 in the denominator. So I got 1.854 plugged into here with this right side highlighted. Okay. I got 0.0319. What'd you guys get?
Hold on just a second.
Brianna, what'd you get?
I got 0.427,
Okay, let me redo it.
but
And I got 1.85.
Oh no, 1.854 for the z-score, but when I plugged it into the probability, sorry.
Oh, okay. So now I have to do the. Okay.
yeah, you're right.
The applet, I got 1.854, and then when I put that in for the z-score, I highlight above the red line because it's above 600. I got 0.0319.
Okay.
That's what I'm getting
That's what
now.
I got.
Yeah, I was wrong.
Okay.
I just want to make sure I wasn't screwing up. Not that, you know what I mean, it happens. We all do it.
Yeah.
So it's to 3 decimals, so it's 0.032.
Oh, 2, 3 decimals. Shoot.
I gotta make sure I didn't put any commas in place of my periods.
0.319. No?
Yeah, but then round to 3 decimals.
0.031.
No, so it'd be .032.
Yeah.
So
Oh,
0.0.
0.032, okay. .032.
But that's only 2 decimal places.
No,
No,
it's .032.
Oh.
0.0.
I'm missing a 0. Okay.
I
Okay.
did the same thing. I did it really fast, and I was like 319, and then I was like, oh no, there's a 0.
Yeah, sorry to make things so
No worries.
rushed.
It's no worries. We're good. It's all good. But we all did the work, so it's all that matters, right?
Yeah.
We didn't just let you give us the answers, so. All right. So you're ready to submit?
Another person too.
Yep. I'm hitting submit.
I'm scared.
Oh, we missed some. What did we miss? That or I put something in wrong somewhere.
I got it.
None of these is correct. It wasn't the variance. So
What?
that's what I understood it to be.
That's crazy. Maybe it's wrong.
Well, I think it must be what Carolyn was saying when we have to type in the probability, but we don't have a probability.
It says none of these is correct. Because I said the standard deviation.
That's what I said too, Carolyn.
Where's my?
All right. Well, if none of these is correct, then
What is it?
I also missed 29 and 30. Did you guys miss those ones?
Let's see.
Nope.
I missed number 15. I don't know how I.
how did we not all miss the same ones? I missed number 15 as well. But
Yeah, I missed.
I missed
14
14 and 15.
I missed 14 and 15, and then we missed.
You didn't miss 12?
No, I didn't miss
Mm-mm.
12.
No.
Yeah.
Just 14 and 15.
On
All right.
12, did you remember the negative sign, Stephanie?
Yeah, I did negative 1.65.
Oh, it's negative
Oh.
0.165.
What?
It's 0.165. Negative 0.165.
Dang it.
Darn
Oh,
it.
sorry.
Yeah. Well, sorry about 14 and 15. I don't know what happened there.
Yeah, I don't know
Is
either.
that what you guys missed was 14 and 15?
Yeah.
No.
So,
What did I do wrong on 29 and 30?
I don't know. What do you have for 29 and 30?
Negative 1.282?
Oh, because you
Okay,
didn't
that's-
find.
No.
Oh, you must not have. You must have taken the z-score and plugged that in instead of finishing out the equation.
I thought I asked you guys, didn't I?
That was the z-score.
Yeah.
The one we were showing you the formula for.
Well, you have to do the 10 percentile, right? So you do 0.10. I haven't.
Well, you used the z-score, but you didn't plug it in to find what the score was. You had to plug that back into the formula to find out what the score was.
Oh,
So see, this is how you would have done it.
yeah, I have it right here,
Oh, okay.
and I just didn't. I guess I was.
We were rushing you.
Yeah, sorry, Stephanie.
Sorry. Don't be sorry. Don't be sorry. Oh well, I still got a B, but oh well. That's all right. I'm gonna redo.
Okay.
Retake.
All right. We're going to let Brianna go because she's got to get a little bit done before her thing. She's still got 15 minutes to do something. Go be
Sorry,
awesome.
guys.
Bye.
Bye. Thank you.
And then we'll